Hi everyone, I am Shubham and this is Attack Graph AI, our entry for Splunk Agentic Ops Hackathon. Our tagline pretty much explains our project. It's a deterministic attack proof for Agentic SOC. So let's start with the problem statement. Today, a single security alert can cost a SOC analyst hours having to manually pivot across logs, trying to reconstruct what actually happened. Also, alerts arrive in isolation, so there is no link between yesterday's events and today's events. On top of that, most AI security tools just hand you an opaque score with no reasoning. And in SOC, a verdict you can't explain is a verdict you can't trust. So here's how we solve it. On the left, the LLM agent lives in its own environment and talks to a MCP server, which exposes our tools. The MCP server proxies those tools into a Splunk agent app through REST endpoints, which trigger our networkx tools.py. The engine reads and writes the knowledge graph into a graph.json and writes the final verdict into verdicts.log. Splunk Studio then parses that log with spath and renders it live. Separately, telemetry is indexed into Splunk search head so the agent can run SPL queries whenever the graph has gaps. Then on the right is the play-by-play. The agent asks for patient 0. The engine returns the entry node. It asks for an attack path, the edges that carry evidence basically. If the path is incomplete, the agent runs a live SPL query, pulls the missing logs, and adds a new edge. Then it calculates hypothesis and notice the graph engine weighs the evidence and the probabilities, not the LLM. Finally, it maps to MITRE attack framework, generates incident report, writes to verdict.log, and the dashboard updates instantly. That's the basic gist of it. And now Samyak will show you guys a demo.
Currently, Attack Graph AI is configured with intelligent alert triggers and evidence weighting patterns for five major security domains. That is brute force, cloud identity, DDoS, lateral movement, and malware and ransomware.
Let's get to a practical workflow. Uh, you'll be giving this data to a Splunk. As you can see, there's some JS injection, OS injection, brute force, and some other attacks still. So, yes. Yes, let's take this data in in the Splunk. So, as you can see, hmm, okay, so data has been added to. We will tell a client to investigate it. So, so yes, we'll just tell the client to investigate it. So it is gonna ask permissions to its tools that we have added. So yes, after a minute or so, it has given us the summary. It has finally generated a report on the Splunk dashboard. So let's go there and select.
As you can see, the final verdict that AI has given is the attack was brute force because it had the highest confidence in that, and it has also given the techniques used. So here is a pie chart that shows the different type of attacks that could have happened with their percentages. Here's a threat count by domain and some other stats. Here you can see the attack path has been marked out. Similarly, here the knowledge graph has been marked out, or from which all nodes the data has been taken. So let's go to the attack graph. As you can see, the final attack graph, it has marked the node from which the attack has started, the path it has taken, and the final affected node.